Yeah, so this is, it's the same CellScope that Dan has used in a lot of his previous research. It's basically just a standard commercial objective coupled with like a very inexpensive optical system and a 3D printed enclosure, which uses a smartphone as the camera. Our addition has been this LED array on top, this massive monstrosity of a circuit board thing. Basically, this is 500 LEDs controlled by an Arduino on the back of this. So you can kind of see that here. And the purpose is we can illuminate our sample from different directions to get different contrast, sort of contrast mechanisms that we would normally have to have different microscopes to get. So you can kind of see the actual LED dome here. So this is all controlled by a smartphone application that we've developed this past year. It's sort of a joint project between myself and several undergrads, and also Dan Fletcher's group. So if I start up the app, I have to connect to the array. So there's a Bluetooth connection, totally wireless, between the cell phone and the LED array. And if I select any, there's several different ways we can program this, but basically, if we do this multi-contrast mode, we can cycle through different LED patterns and acquire different images. So you can kind of see the LED array changes there. And if we had a sample, you would see the sample in different ways every time. So with this, you can get phase contrast, bright field, and dark field imaging, which is really advantageous because those are three separate microscopes, or at least mechanical inserts that we would use normally. And microscopes are like $10,000 or so. So that kind of brings me like this whole device here, minus the cost of the smartphone, is about $1,000. And that's our first iteration, so we think we can get it to at least half that cost eventually.
Tell me just quickly your name and affiliation.
I'm Zack Phillips. I'm a grad student in Laura's lab.
Thank you.